So learning outcome 2, what it says is identify the structure and function of cells, tissues, and chemicals of the human body in relation to the physiological processes that support health and well-being. So that's a really complicated sounding question there. Basically what it's saying is tell us about cells, tissues, and chemicals and how they work in the body. That's all it's really saying. It's a stupid way of saying that. It's pretty overly complicated. So what it is, I mean, we know that tissues are made of cells and chemicals, so we know that's basically just telling us how tissues work and what chemicals make them up, basically what it's saying. So for each system, there's kind of slightly different things for that. And then, processes that support health and well-being, that's just meaning to make the body work. It doesn't mean anything else. They've just used fancy words to make it sound like that. Okay, so what I'm going to do is I'm going to go through a question here, and we'll have a look at a question, and then we'll kind of see how we would answer it. So for this one here, we've got, what is the role of B cells in immune response? So here we're talking about the immune system, and then we're talking about cells, because the learning outcome said about cells, tissues, and chemicals. Okay, so the role of B cells in immune response. This is a question from the exam, and what we're looking for here is we know that the B cells are in the adaptive immune system. Okay, so we're talking about here our second line of defense. So once the pathogen's made it into our body, and the role of B cells is to produce antibodies. So we're looking for something about producing antibodies and then building a memory of that pathogen so that they can produce antibodies again next time. Okay, so that's what we're looking for there. Just answering what B cells do in immune response. Their response is to produce antibodies in response to a pathogen they've encountered, and then remember it for next time so they can do it again. Okay, so learning outcome 2, cells and tissues, what they do, and chemicals, and what they do in the body. It's stuff we've covered already in the papers. It's not any real interpretation or anything like that. It's just knowing what those words are. Another question we could do, it's not up here on the slides, but if we think of what is the function of calcium in the muscular system? Okay, so we've got here calcium, a chemical, and then it's in the muscular system, and it's relating to cells, so it's kind of covering off 2 parts of that as well. So if we had a question, what's the function of calcium in the muscular system, we'd say we'll be looking for something like it triggers the actin and myosin filaments to connect and pull along to contract the muscle cell, something like that. So the function of calcium is muscle contraction. It makes actin and myosin bind and then pull along. Something like that will be out there. So again, we're covering off a chemical there, and its work within cells. Okay, so again, it's stuff we have covered in class. It's nothing that you're not going to know. It's just being aware of those. Okay, so that's our learning outcome 2. Our next learning outcome 3. Explain the homeostatic mechanisms to maintain internal balance across stages across a lifespan. Okay, so this one here, homeostatic mechanisms is a funny word. We might kind of recognize that, but not quite. We just said, homeostasis. That's what that is saying. So mechanism is just the ways homeostasis works in each system. And then to maintain balance, that's saying homeostasis again, so it's kind of double saying the same thing. At stages across the lifespan. So that's the only different part there. We're talking about different parts of someone's age. So at stages across the lifespan, we'd probably talk about childhood, we'd probably talk about adulthood, and we'd talk about old age. Those are the kind of the areas where there's difference between them. You can maybe say teenage years as well, but we're not going to worry too much about that. So explain homeostatic mechanisms to maintain internal balance at stages across the lifespan. Okay. So a question here, if we've got one here. So during exercise, the body's cardiovascular needs change. Okay, so we know that things change when we exercise. Name 2 ways that the cardiovascular system adjusts to cope with these changes to try and keep the body in homeostasis. Okay, so this is it's quite a long question here. There's kind of 2 parts that we need to understand. So we need to understand that our cardiovascular system changes when we exercise. Yes, we're probably all aware of that pretty well. So 2 ways that our cardiovascular system adjusts to cope with this. Okay, so you think about if you're exercising, what things would happen. So it doesn't have to be, if you don't like exercise, just think about times when you had to run for the bus, or times when you're late for class or something like that. Yeah. So responses in your body would be things like my heart rate increases. Yeah. Because my muscles and things need more blood pumped to them. So my heart rate increases. It goes faster to try and get blood to my muscles and areas of my body that are working. Another one we could say is my blood pressure increases. So again, to get that blood around faster, my blood pressure increases to push it out there faster. We could also say my stroke volume increases. So I'm pumping more per pump out of my heart because it's trying to get, again, more blood to my muscles and the parts of my body that are working. Okay, so you need to name 2 changes. You don't have to explain them. You just had to name 2 changes there for that. So that would be an answer there. There was a question in the exam around bone density changes across the lifespan. Okay, so again, that would come under this question here. So bone density changes, we would say, if we look at children, bone density in children it's quite, the bones aren't as hard, but they're very flexible. Yeah, and so children get things what we call green stick fractures. They don't actually break bones properly a lot of the time. They just kind of like half snap it, and it kind of it breaks a bit like if you've got a really green stick and you try and break it, they have that. So their bones in children would say are flexible and softer. Yeah. When we get to adults, the bone density there would be adults' bones are a lot stronger. They're able to carry a lot more load. So we get that. And then if we look at older people, we'd say their bones are less dense, they're more brittle, and they're easier to break. Just because as they age, the cells within the bone change their function. We have less osteoblast activity, we've got less bone building going on. So yeah, the bones are less dense. The question was the bone density changes across the lifespan. You didn't have to explain that, you just had to say what was happening at each stage. So children, softer, more flexible. Adults, harder, more dense bone. Old age or elderly people, we would say the bones are less dense and more fragile and brittle, easier to break. That will be it. That's all we need to answer for that. Okay, so if we just go back to the thing we said, there's the homeostatic mechanism. So what in homeostasis, what's happening, and then what across the lifespan. So if it says across the lifespan, it means comparing young, adult, old age, like that. Okay, again, we'll work on these more. If you've got any more questions, bring them along on Monday and we can go through that. Okay.